Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. We will continue now. As we said in the first part, you're going to solve a question like this by rewrite it. Instead of cosine times sine, I remember that we said complete the rule, multiply by 2, then divide by 2, and use double angle. Now we're going to solve the same question, but using product and or quotient rule. I think here product rule will be valid. Again, the first function is u, so u equals cosine x. Then differentiate it. Derivative cosine is negative sine x. V, or the second function, is sine x. Derivative of sine is cosine x. I repeat, use the auxiliary diagonal. So f dash of x will be sine times negative sine, in which is negative sine squared x. Cosine times cosine, in which is positive cosine squared x. Do you remember the rules? We said it by the end of the last time. We said cosine squared minus sine squared stands for what? Yes, perfect. Cosine 2x. Now, we're going to differentiate it again. So, f double dash of x will be derivative cosine is negative sine 2x times 2. So it is negative 2 sine 2x. That's it. Okay? Let's go now to the next question. It is page 135 in your textbook. Differentiate with respect to x. To differentiate here with respect to x, you have to notice that e power negative 3x times cosine 2x will lead to product rule. Okay? The first function is e. Its derivative is e power negative 3x times the derivative of the power in which is negative 3. V equals cosine 2x. So v dash is derivative of cosine is, yes, negative sine times derivative of the angle in which is 2. So the derivative will be negative, try to rearrange it, negative 3e power negative 3x multiplied by cosine 2x minus 2e power negative 3x sine 2x. If there is a common factor, please try to take it. We can take negative and e as a common factor. Negative e power negative 3x remains 3 cosine 2x plus, what is the remainder here? 2 sine 2x, and this is the simplest form. Let's go to the next idea. Here we have fraction. Let's read it again. E power x over sine x. We going to read x twice. Whenever you read x twice, it means this is product or quotient. Product means times, quotient means divide. Okay? Here we're going to use the quotient rule. So u equals the upper, in which is e power x. By the way, it's not permitted to change the positions. You have to take the upper as u, the lower as v. Never to change. Derivative e as it is, multiplied by derivative of the power, in which is 1. V is sine. Derivative sine is, yes, perfect, cosine. Multiply derivative of x, in which is 1. No need to write it. So let's use our rule here. The rule is v u dash minus u v dash over v squared. We will return back to the rules later inshallah. So now replacing v u dash and u v dash over v squared. Don't forget about the common factor. E power x here valid. Remains sin x minus cosine x over sine squared x. And this is the simplest form. Type. Never ever to cancel sine with power and or put cosine over sine. Why? Because here count 1, 2, 3. To simplify, you have to simplify from the 3 terms. Never to simplify from 2 terms and leave the 3rd term. Now we're going to a new idea. Find the value of x between 0 and pi, for which e power negative x cosine x is a stationary. It is the same idea as we said before, but here he rephrased the question. The answer of the values of x must be lies between 0 and pi. Type. Are we going to change the domain here? No. Why? Look, it is e power negative x cosine x, x and here x, so they are identical. There is no changes. U is e power negative x, so u dash, to differentiate e, multiply it as it is, then multiply by derivative of the power, in which is, in this case, negative. V cosine, so v dash equals negative sine times the derivative x, in which is 1. No need to multiply it. So y dash equals 0. As we said before, stationary means y dash equal 0. Type. Where is y dash here? It is negative e power negative x cosine x. Negative e power negative x sine x equals 0. Type. Take e power negative x and the negative sign also as a common factor. Remains cosine x plus sine x equals 0. This term approach 0. This term never ever equal to 0. So the only solution here is cosine plus sine is equal to 0. To solve this, you have to take a common factor. Do you remember? Tan x equals sine over cosine. That's why each time take cosine x as a common factor. Remains here cosine over cosine, in which is 1. Sine over cosine, in which is tan. So cosine x equals 0 or tan x equals negative 1. Negative 1 again means lies in 2 quadrants, first or third, first or third. How to evaluate? Using your calculator and write shift tan 1. I think it is pi over 4. Pi plus pi over 4 leads to 5 pi over 4. Here cosine x equals 0. The graph of cosine is like this. Do you remember these 2 points? Yes, perfect. Pi over 2 and 3 pi over 2. After getting this solution, I prefer to check. This solution اللي هو leads أو coming from the common factor sometimes will be not accepted. That's why I prefer to check it. طيب, let's return back to the question, please. Let's return back the question. What is the required? There is the required here is to get the values of x only. No need to make any extra steps. Okay? Never to get y, never to get the nature of the point. No need for this. Try to answer the question, then go directly to the next question because you have no time at the final exam. Now, the next question is, this is direct. Differentiate with respect to x, y equals ln 1 plus cosine over 1 minus cosine. What did we say last time? When you have ln, please use the rules of ln first of all. After this, go to the rules of differentiation or integration. Type. What is the rule of ln here? When we have a over b, we can make it like this. Ln 1 plus cosine minus ln 1 minus cosine. Now, how to differentiate? To differentiate ln, just write the function as it is down. 1 plus cosine x. Up, it's a derivative. Derivative of cosine is negative sine. Here, 1 minus cosine x. Derivative of cosine is negative sine, and here don't forget this negative, it comes to be sine x equals, here we have two different denominators and no need to make any more steps. You may stop here, it's okay. Or if you want, multiply the denominators to get 1 plus cosine, and here 1 minus cosine. Cross multiply leads to negative sine, positive sine cosine, and here the cross multiplication will be negative sine again, negative sine cosine will be cancelled. Here 1 minus cosine squared, here negative 2 sine x. 1 minus cosine squared leads to negative sine squared, and here negative 2 sine x. Negative cancel with negative, sine with power, يبقى remains 2 over sine x or 2 cosec x. Okay? طيب, the next question. Wait a minute here بقى. Here we have some rules in which is derivative of tan is sec squared, derivative of sec is sec tan, derivative of cotan negative cosec squared, derivative of cosec is negative cosec cotan. These rules will be given at the formula sheet. But what if we have question like this? Prove that derivative tan is sec squared, or sec is sec tan, and so on. To prove that you have to solve it as if it is a question. Instead of tan, you may write it sine x over cosine x. Now you have u and v. U is sine x. U dash, derivative sine is cosine x. Cosine x. V is cosine x. V dash is derivative cosine is negative sine x. The auxiliary diagonal will be cosine by cosine, in which is cosine squared x. Sorry for this line, no need for it. And here negative leads to positive, sine squared x over cosine squared x. Sine squared plus cosine squared is, yes, 1 over cosine squared. 1 over cosine squared. What is the reciprocal of cosine? Perfect, it is sec. And here square يبقى leads to sec square. This is the right hand side. Let's repeat it again. Listen carefully, please, all of you. The rules, these rules will be given in the formula sheet. يعني in any ordinary question, if it is required to, or if you're looking for derivative of tan, replace it by sec squared directly like this, just like that. But I'm talking about a different idea of the questions. If it is given like this, prove that derivative tan is sec squared. What are you going to do? You're going to do it like this. Is it clear? Type. By the same way, you may differentiate any of these if it is required to prove that. Type. For question like this, here, differentiate with respect to x. Root tan x, يعني it is required to get d by dx root tan x, in which is tan x raised to power half. How to differentiate this? Chain rule. Drop the power. Do you remember? Subtract 1. When you subtract 1, you will write it on the rule calculator. Half minus 1. It gives negative half. Time derivative, the function. What is the derivative of tan? It is sec squared x. Are we going to prove this? No. We're going to use it. Why? Because it is not required to prove that tan, our derivative tan, is equal to 6. Is it clear now for all of you? What are you going to do? Just rewrite this equation. To rewrite it, 2 will be down, negative power will be down, and 6 squared as it is up. 6 squared x. And no need to simplify anymore. خلاص. Next question. Here it is required to get the equation of the normal. Above normal, let's write what are we going to get to the curve when x. Where is y? Y is not given. Do you remember when we say to get equation of any straight line, you have to get equation of normal, or to get equation of normal, you have to get point and gradient. يبقى first of all, to get y, put x pi over 4. From where we got pi over 4? It is given. Never ever to put any number or any arbitrary number. You have to use the numbers from the given. Okay? To get y, put x equals pi over 4. So y equals tan squared pi over 4. Tan pi over 4, in which is 1. So tan squared pi over 4 will be 1. After this, you're going to get the gradient. How to get the gradient? Just differentiate. Y dash equals. How to differentiate tan squared x? Just drop the power, subtract 1, time derivative tan, in which is 6 squared x, time derivative x, in which is 1. So m equals, that's what we call gradient function, but we're looking for gradient. So m equals 2 tan pi over 4, 6 squared pi over 4. 2 tan pi over 4, 6 squared pi over 4, in which is, you may use your calculator. Use your calculator, it will be 4. How to evaluate it? Tan pi over 4, tan fraction pi over 4. Sec, there is no sec in your calculator. That's why you're going to write it 1 over cosine squared, or 1 over cosine pi over 4. Inscribe it in a bracket, all power 2. Anyway, m equals 4. But here we're looking for m normal. Again, to get m normal, just negative flip. Instead of 4, it will be negative 1 over 4. Okay? Equation of straight line, y minus y1 equals m x minus x1. So, y minus. Where is y1? Let's try to get it. Yes, y1 is 1. And x1 is pi over 4. خلاص, no need for this. We can go. Yes, please. Y minus, we said 1, equals m perpendicular, in which is negative 1 over 4, x minus pi over 4. I prefer to make y subject of the formula. So it is negative 1 over 4x, positive pi over 16, and this negative 1 becomes positive 1. You may multiply by 16 or leave it like this. Next question. Let's read it carefully. What is this? It is required to get dy by dx. What does it mean? It means the equation must be y equals or y subject. But here x is subject. It doesn't matter. Get dx by dy, then flip. Is it clear for all of you? أهو. X equals 1 over 4 sec 4y plus 1. So, dx by dy will be, forget about the coefficient, rewrite the coefficient. Derivative sec is sec tan 4y plus 1. 4y plus 1 from the formula sheet. Multiply by derivative 4y, sorry, in which is 4. 4 cancel with 4. This is dx by dy. But the required here is to get dy by dx. So you just flip the answer, in which is 1 over tan 4y plus 1 sec 4y plus 1. Next. Here, differentiate with respect to x. 2 cotan 3x. It's a very easy and very direct question. Try to think about it. What are you going to do? D by dx, 2 cotan 3x. Yes, perfect. Forget about the coefficient. Derivative cotan is negative cosec squared time derivative, the angle is 3. Here some students asking, why we will not write here 3 squared? Because the answer, because the angle here is not squared. Cotan, the trigonometric function, becomes cosec or negative cosec squared, while the angle as it is, the angle is 3x. يبقى never to put square here. Equals negative 6 cosec squared 3x. Yes? Let's read this question carefully. Why? Because some of you, when see len sec plus tan, think in wrong way. What is required here? It is required to get dy by dx and show that it is sec x. What is the idea? First of all, write the derivative. How to differentiate? What do we have? What is the main function? It is len. Type. How to differentiate len? Put the function as it is down, then differentiate it up. What is the derivative of sec? From the formula sheet, it is sec tan. What is the derivative of tan? Again, from the formula sheet, it is sec squared. What's your mind if we take sec here as a common factor? I have advice for you. Whenever you have two terms, try to take a common factor. Sec and sec squared. Put sec here, open brackets, tan and sec again, over sec plus tan. It is the same, so you may cancel. Leads to sec x, in which is right hand side. Let's count 1, 2, 3 steps. Only 3 steps. Okay? Take care of this. Now we're going to take some questions from the past papers, some ideas from the past papers. منين توقف منين هنا؟